Okay, here's our video on negative exponents. So let's put an example here. We have 2 to the negative 2 power. So when you see a negative exponent, you're going to make a fraction. So the base of 2 will become half. Right? Whatever the base is, whatever number it is, you just make a fraction. You put the base number in the denominator. Okay, so if it's 2 to the negative 2 power, it's going to be 1/2 to the second power. You bring the exponent down into the denominator, and it's 1/2 to the second power, which will equal, in standard form, 1 to the 4th power. Okay, let's do another one. So again, anytime you see a negative exponent, you've got to bring it down into the denominator of the fraction. So here we have 5, so we know we're going to have 1/5, and we'll bring the exponent down. So it'll be 1/5 to the 3rd power. And this is in exponential form, but if we want to put it in standard form, and sometimes I'll ask you to put it in standard form, you just have to solve it. Right? So that'd be 1 over 125, because 5 to the 3rd power is 1 over 125. Okay, let's do a few more examples. So let's say I had, bring this up, what would this answer be? Let's say I had 4 to the negative 3rd power. Let's make that negative 3 better. 4 to the negative 3rd power. What would that be in exponential form? Well, okay, remember we're going to bring the 4 down into the denominator, and the negative exponent goes into the denominator as a positive number. So that's in exponential form. And in standard form, be 1 over 64. Okay? So remember, with negative exponents, bring them down into the denominator when you make the fraction. And when you have negative exponents, you make fractions. So let's look at a multiplication problem. Okay, let's bring that over there. Here we have 2 to the 4th power times 2 to the negative 5th power. So remember the law of exponents. We're going to keep the base. We're going to keep 2 and add the exponents. And 4 plus negative 5 is negative 1. So now we know we can make this a fraction. 1 over 2. And we can just leave it 1 over 2 because we know the 1 is invisible. Or you can just leave it like that. But the answer is half. Okay, let's do a division problem. Let's say I had 12 to the negative 5 divided by 12 to the negative 6. Okay, so we have the same base, so we can keep the base as 12. And there's two things we can do. I'll show you the first one. First, it's negative 5 minus 6. Right? A common mistake, and a lot of students do this, is do negative 5 minus 6. It's not negative 5 minus 6. It's negative 5 minus 6. Remember, in division we subtract, and we're subtracting a minus 6. So we keep change, and we're going to have 12 to the 1st power, or just 12. Now, there's another thing we can do. If we remember the law of exponents, negative exponents, when you have a negative exponent in the numerator, you bring it down in the denominator, and it becomes positive. The same happens if you have a negative exponent in the denominator already. You bring it up to the numerator. So you could just flip this. You could say 12 to the 6th power over 12 to the 5th power. 6 minus 5 is 1. You get the same answer. Okay, let's do another one. Let's say I had 7 to the negative 3rd power and 7 to the 5th power. Okay? So here, we're doing minus 3. We have the same base, so we keep the base 7. And it's a minus 3 minus 5 now. And we keep change. And we're going to have something like this. We're going to have a negative 8. Again, when we have a negative exponent, we make a fraction. So this is 1 over 7 to the 8th power. Okay, now let's do one with variables. So let's say I had 8. Bring this over. Let's say I had 8x to the negative 3 divided by 2x to the negative 5. How would we do this? What do you think? Remember, the 8 and 2 have no exponents, so you can just divide them, right? They don't have to have the same base, because there's no base. They're just constant. So this will be a 4. They're not part of the exponents. The variables are the ones with exponents, and they have the same base. They have x. Right? And now with division, it's minus 3 minus a minus 5. Right? And we just keep change. So it'll be negative 3 plus 5, which will be 2. That'll be our answer. Right? And let's say we had another one. Let's do 16 x to the negative 5 over 8 x to the, let's say, the second power. Again, the 16 and the 8 are not, they're just constants. They don't have, they're coefficients. They don't have exponents, so we'll just divide them, and it'll be 2. They have the same base of x, and a negative 5 minus 2 is negative 5 plus negative 2. Keep change, and you get a negative 7. Now with this, let me bring this up so you can see this. With this, the 2 stays in the numerator, but the x has a negative 7. Remember, that becomes a fraction. So the x actually goes down in the denominator, and that'll be your answer. Okay, because you're actually doing 1x, 1 over x, and 2 times 1 is 2, so that's what remains there. Let me do one more like that so you understand it. So let's say I had 10 x to the negative 6 over, and we'll just say 5 x to the third power. So try that. 10 divided by 5 is 2. They have the same base of x, and a negative 6 minus 3 becomes a negative 6 plus negative 3, which is negative 9. We've got to keep going now. So the 2, it stays in the numerator, but the x goes down because it has a negative exponent. And that'll be the answer. So we'll do more with variables in the next video.